morning, students. So today we are going to start the next lecture, that is nothing but water lecture number 18 in case of heat and thermodynamics chapter, in which we will be discussing about second set of assignment what we had sent to your number. Okay, so without wasting the time, please take that a second assignment in your copy, and we'll be proceeding with that solutions part now. So given that, first question they are asking, state and explain first law of thermodynamics. So what is the first law of thermodynamics states? Statement of first law of thermodynamics. Delta Q is nothing but water, delta U plus delta W. The amount of heat given to the system is equal to increase its internal energy and to do external work done. So that statement also you should have to write down and explain all the things present in that first law of thermodynamics. Next, what is the significance of first law of thermodynamics? Significance or importance of first law of thermodynamics is nothing but what? U. U stands for what? Internal energy. Okay. Next, what is isothermal and adiabatic processes? Isothermal process means constant temperature. Okay. Adiabatic means exchange of heat will be equal to what? 0. Okay, no exchange of heat will be present in case of which process? This one, adiabatic process. Next question we had given, in which process pressure of the system remains unchanged? Draw the PV diagram for adiabatic process. In which process pressure of the system remains unchanged? In which process pressure value will be what? A constant. Pressure is constant in which process? Isobaric process. So this stands for what? Isobaric process. Okay. And draw the PV diagram for adiabatic process. Listen, whenever you are drawing PV diagram for adiabatic process, graph should be not smooth in this manner, but sudden decrement should be there. You should not draw like this. This is for isothermal. Okay. So while explaining slopes and all, I had told you this. Okay. So sudden decrement will give you which graph? Adiabatic process. Clear? Now, next question. Next question. Which quantity is kept constant in adiabatic process? In adiabatic process, which quantity will be kept constant? Anybody know? Don't know? Heat value will be kept what? Constant. Okay. That means delta Q value will be equal to what? 0 in case of adiabatic process. Next. Using first law of thermodynamics, arrive at the relation Cp minus Cv is equal to R. Listen. About this question number 6. Cp minus Cv is nothing but R stands for, this is question number 6. Cp minus Cv is equal to R. This is known as a Mayer's relation. So in kinetic theory of gases already I had discussed this part. Okay. So what you can do means, in my channel only, in kinetic theory of gases, you will be going to get this concept. Okay. Already I had uploaded the video. You can go and cross check over there. Okay. Next, just hold on 1 second. I'll be telling you in which video you will be going to get this derivation. Okay. From theoretical point of view, this concept we had used in thermodynamics chapter, but derivation of this board is included in kinetic theory of gases. That's why we had discussed in that this chapter. So go to kinetic theory of gases playlist. Otherwise, kinetic theory of gases in a set only I had uploaded the video. I hope I had not yet made that playlist over there. So in video number, okay, in 6, that means kinetic theory of gases, lecture number 6, I had did this derivation, Mayer's relation. You can go and cross check over there. Okay. Next question, we are having 7th question. What do we mean by refrigeration? Refrigeration means what? I hope in your previous class only we had discussed what do we mean by refrigeration. So what do we mean by refrigeration then? Can anybody tell me what is refrigeration? Refrigeration means what? It is the process where we are going to extract the heat from a body which is present at lower temperature, and we are going to give that heat for the body which is present at higher temperature. That is nothing but what? The process which we are going to call it as what? Refrigeration. Next, state second law of thermodynamics as given by Clausius. So what is Clausius statement? It states that heat cannot flow from a cold body to a hot body without performance of work by some external agency. Okay, in previous class only we had discussed what do we mean by what? A Clausius statement. Okay, second law of thermodynamics given by what? Clausius. So what is the efficiency of Carnot's engine when T1 is equal to T2? Listen. Efficiency of Carnot's engine is nothing but what? 1 minus T2 by T1. If T1 is equal to T2 means this factor will vanish and it will become what? 1. That means efficiency value will be equal to what? 0. Correct, no? So efficiency is equal to 0 means what is the meaning of that? If T2 is equal to T1 means what will happen? Efficiency value will be equal to what? 0. The amount of heat energy which has been extracted from that source, that means which has received from the source, complete amount of heat energy is going for where? Sink means value will be equal to what? 0. Okay. Now next question. Explain the working principle of Carnot cycle with the necessary PV diagram. So for this question you should have to do complete process about Carnots, that means sink, source, okay, and that insulated stand, working substance, okay, 4 sets, expansion, compression, okay, those all things. 2 times first initial to 2 times expansion, then 2 times compression. So those all completely in detailed manner you should have to write about this one. Next, we are having the next question, question number 11. So listen, questions, numerical questions what we had included is important. Please go through this numerical questions in a stretch only. Listen, a steam engine delivers 6.4 into 10 to the power of 9 joule of heat, okay, joule of work per minute and serves 4.6 into 10 to the power of 10 joule of heat per minute from its boiler. What is the efficiency of the engine and how much amount of heat is wasted per minute? Listen, how to solve these kind of question. Very easy question only. You have to remember some terms over here. Okay, whenever you are writing over here, you should have to remember some of the things. A steam engine delivers 6.4 into 10 to the power of 9 joule per minute, joule of work per minute. That means what they had given in our question, joule per minute means that is nothing but what? Work done. Work done value they are giving 6.4 into 10 to the power of 9. 6.4 into 10 to the power of 9. Joule per minute. And next they are telling that answers 4.6 into 10 to the power of 10 of heat per minute from its boiler. Okay, and serves 4.6 into 10 to the power of 10 means this is our Q value, which is nothing but 4.6 into 10 to the power of 10 joules. So what they are asking, efficiency and amount of heat wasted. Efficiency is nothing but simply W divided by Q. Okay, output work divided by input energy what we had fed it. So from this one what you are going to calculate, efficiency is equal to W value 6.4 into 10 to the power of 9 divided by 4.6 into 10 to the power of 10 means this value you are going to get the 0.139, or if you multiply with 100 means 13.9%. Okay, answer how much they had given? 13%. Okay, next, amount of heat wasted means, listen, heat wasted means how much energy we had sent, okay, in that how much work it is doing. The remaining amount of energy is nothing but what? Amount of heat wasted. So if you calculate Q minus W means Q value is nothing but what, 4.6 into 10 to the power of 10 minus 6.4 into 10 to the power of 9. So write this in terms of 10 to the power of 9 and 10. So it will become, into 10 means it will turn out to be 46 into 10 to the power of 9 minus 6.4 into 10 to the power of 9. So take 10 to the power of 9 common. 46 minus 6.4 is nothing but 39.6. And already 10 to the power of 9 factor we have taken common, means this is nothing but this much amount of heat is wasted per minute. Okay. So simple question only, but you should have to correctly you should have to judge which is W and which one is Q. Eta is nothing but what, W divided by Q, and Q minus W is nothing but what, amount of heat wasted. Clear? Next. In next question, 12th question, we are having the Carnot's engine takes 2090 joule of heat per cycle from the source at 400 Kelvin and rejects 1670 joules to the sink. What is the temperature of the sink? What is the efficiency of Carnot's engine? Listen. So in this question they are talking about Carnot cycle, amount of heat, how much it is taken from the source, okay, temperature, these all factors. Listen, 12th question. Temperature of the source treated as T1 and they are telling temperature of the source is how much? 400 Kelvin. Clear? Next. Heat transfer from the source. That means heat transfer means value will be Q. From the source meant treated as 1. So Q1 value is nothing but what? 2090 joule given to you. Next, amount of heat rejected to the sink. This value Q2 they are giving us 1670 as the value, 1670 joules basically. Next, temperature of the sink they are asking. That means temperature of the sink means treated as to this one they are asking. So what is the simple process to calculate T2 means? Listen, for Carnot cycle we are going to treat as T1 by T2 is equal to Q1 by Q2. Okay, T1 by T2 is equal to what? Q1 divided by Q2. From this one, if you separate T2 means what you are going to write? T1 into Q2 divided by Q1 is nothing but what? T2. That's why T2 is equal to what? I can tell T1 Q2 divided by Q1. Shall I erase this part? T2 is nothing but what? So we were in question number 13 or 12th one? 12th question, correct now? So T2 is equal to what we got? T1 into Q2 divided by what? Q1. Substitute the values and you are going to get that temperature of the sink. So T1 value given us, value is 400, Q2 value 1670, Q1 value 2090. So if you calculate this ratio means you are going to get a 319.6 Kelvin as temperature of sink T2. Okay. Next, efficiency they are asking. What is the efficiency formula? Eta is equal to 1 minus T2 by T1. Where T1 is temperature of the source and T2 is nothing but what? Temperature of the sink. Temperature of the source given in our question value is 400 Kelvin and temperature of the sink just now we had calculated, that is 319.6. So 1 minus 319.6 by 400. So this value will turn out to be 319.6 by 400 will turn out to be 0.799, or this complete value we are going to get a 0.201, or we can tell it as 20.1%. Clear? 20.1%. So always remember, for Carnot cycle we are going to treat Q1 by Q2 is nothing but what? T1 by T2. Okay. Using this rule we had calculated the value for temperature of sink T2. Okay, shall we go to next question? Okay. Next 13th question is, a sample of 0.1 gram of water at 100 degrees Celsius and at a normal pressure 1.013 into 10 to the power of 5 Newton per meter square requires 54 calorie of heat energy to convert that is pressure in bracket that given 1.013 into 10 to the power of 5 Newton per meter square. Okay, requires 54 calorie of heat energy to convert steam at 100 degrees Celsius if the volume of the steam produces 167 cubic centimeter. Cc means cubic centimeter. The change in internal energy of the sample is. Change in internal energy of the sample. Change in internal energy of the sample means what they are asking, delta U value they are asking us. Okay, delta U value is equal to what? A question mark. So from first law of thermodynamics what we are knowing, delta Q is equal to first law of thermodynamics, amount of heat given to the system is nothing but utilized to increase its internal energy and external work done. So now delta Q value, they are telling that value is how much? 13th question, 54 calorie of heat energy. 54 calorie of heat energy. Okay, 1 calorie is nothing but what? 4.18 joules. So convert this into joule completely is equal to delta U value. We should have to calculate, keep it as delta U plus delta W. Now this is most important. Delta W means, listen, delta W is nothing but pressure into delta V. P delta V. Pressure value given as 1.013 into 10 to the power of 5 inside the bracket. Volume is nothing but difference between volumes. Okay, initial volume 0 and final volume is 167.1. Okay, 167.1 cubic centimeter. 167.1 cubic centimeter. Centimeters 10 to the power of -2 whole power 3 minus 0. If you solve out this equation and separate value for delta U means that is your value for delta U. Okay. So shall I calculate over here? This value you are going to get 225.72 is equal to delta U plus, here if you calculate all these fact means you are going to get 169.2 into 10 to the power of -1 or 169.2 means I can change this decimal here. I will erase this decimal and into 10 to the power of -1. Now delta U is nothing but what? 225.72 minus 16.92 means value we are going to get 208.8 joules. Clear? Are you getting this point? Getting or not? Or shall I tell you once again? Delta Q value they had given 54 calorie. Convert this into joule. Okay, by multiplying 4.18. Delta U as it is because they are asking delta U. Delta W is nothing but work done is nothing but what? P delta V. Okay, this is nothing but what? Delta W or W is equal to P delta V. From that equation you are going to calculate this part. Okay. So ultimately you are going to get a delta U value will be equal to 208.8 joules. Okay. Next question. First law of thermodynamics is a consequence of conservation of. So while starting this first law of thermodynamics, I had told you first law of thermodynamics is nothing but what? Another law for law of conservation of energy. Okay, here only you are having that part. Okay, heat energy, internal energy, work done. Law of conservation of energy. Okay. Next question, 15th one. Which of the following is not a thermodynamical function? So 4 values given: enthalpy, work done, Gibbs energy as well as internal energy. Listen, among these 4 options, thermodynamic function means path independent value, but work done is path dependent. That's why work done is not a state function. Gibbs energy, enthalpy as well as internal energy, these are path independent, and these factors will depend only on initial as well as final position. So number of times I have told you, keep it in your mind, note it down somewhere. And while discussing in our previous videos also, I had told you, write down. Next, in which of the following processes heat is neither absorbed or released by the system? Which is the correct option over there? Option number C. Okay, adiabatic process means no heat is going to enter inside the system and no heat is going to go outside of the system. Okay, next question. Next question is very interesting question, 17th question. So what they are giving in our question means, 17th question, the efficiency of ideal heat engine working between freezing point and boiling point of water. Now tell me, freezing point of water as well as boiling point of water means, what is the meaning of this one? Efficiency of ideal heat engine they are asking. That means efficiency for heat engine is nothing but 1 minus T2 divided by what? T1. Okay. Now T1, T2 value directly they had not given, but in question what they are giving, the efficiency of an ideal heat engine working between freezing point and boiling point of water. Freezing point means your T1 value, okay, as well as the boiling point of water means, freezing point means this one T2, okay, and boiling point of water means T1. Okay. Now, how to take these values? Freezing point means what? Freezing point of water is nothing but 0 degrees Celsius or 273 Kelvin. So freezing point is nothing but what? Our T2 here. So T1 is boiling point of water. Water will boil at 100 degrees Celsius or 373 Kelvin. Substitute 273, 373 in place of T2 and T1. You are going to get the answer. So eta efficiency is equal to 1 minus T2 value is 273 by T1 value is 373. So 1 minus 273 by 373 is nothing but what value? 0.73. So value will be, if you are going to multiply with 100 percentage means for this value, you are going to get a 26.8 percentage. Clear? Are you understanding? Shall we go to next question? So in this question they are telling that freezing point and boiling point of water. So water will start freezing at 0 degrees Celsius and starts boiling at 100 degrees Celsius. So 0 degrees Celsius in Kelvin scale value will be 0 plus 273, which is nothing but 273 Kelvin. 100 plus 273, which is nothing but 373 Kelvin. Clear? Shall we go to next question? So next question, question number 18. A refrigerator works between 4 degrees Celsius and 30 degrees Celsius. It required to remove 600 calories of heat every second in order to keep the temperature of the refrigerated space constant. The power required is, okay, power they are asking, and take 1 calorie is equal to 4.2 joules conversion value they are giving in that. Okay. Now listen how we are going to discuss about this question. So question number 18. So we know that beta is nothing but what? A Q2 divided by total work done. And one more equation we know that for beta, that is nothing but what, T2 divided by T1 minus T2. Okay. By combining these two equations, what I can write? Right side means Q2 by W is equal to T2 by T1 minus T2. Correct? Q2 by W is nothing but T2 by T1 minus T2. Okay. Now, what we are going to do, substitute the values over here and separate the value for work done. Work done value, if you are separating, means, listen, W is equal to what we are going to get, a Q2 by T2 inside the bracket T1 minus T2. Now what is Q2 value? Q2 is nothing but 600 into 4.2. Correct now? Getting 600 calorie into 4.2. 1 calorie is equal to 4.2 joules. Next, T1 minus T2. T1 is 303 minus T2 is 277. Whole divided by T2 means 277. Work done value you are going to get over here. This value will be 236.5 joules. 236.5 joules. Clear? Now, power is nothing but what? Work done in unit time. So they are talking about here about 1 second analysis. That's why P is equal to W, or P is equal to W value is 236.5 joules. Clear? So P value we got 236.5 joules. Clear? Getting or not? Okay. Now next question. 19th question. Which of the following process is reversible process? So 4 options we had given. Among those 4 options, which is the correct option, we should have to identify. Transfer of heat by conduction, transfer of heat by radiation. Third one is isothermal compression. Fourth one is electric heating of a nichrome wire. So among these 4 options, isothermal compression is a reversible process. Okay, option number C. And next, 20th question. A Carnot's engine having an efficiency of 1/10 hours of a heat engine. So shall I erase this part? Okay. So in 20th question, a Carnot's engine having an efficiency of 1/10 of heat engine, it is used as a refrigerator. If the work done of the system is 10 joules, the amount of heat energy absorbed from the reservoir, which is at lower temperature, is. Listen. So first of all, we know that eta is nothing but what? W divided by QH. Okay. QH means what? Amount of heat added to the system. W means work done. Eta is nothing but efficiency. If you separate QH from this, means QH is equal to W divided by eta. So W value they are giving 10 and eta value is 1/10. This is nothing but what? 10 will come to numerator, it will become 10 into 10, 100 joules. This is nothing but QH. Next, the factor what they are asking, that is nothing but not QH but QH minus W factor they are asking. So basically they are asking about what? The amount of heat energy absorbed from the reservoir at lower temperature. That is nothing but what? 100 minus work done value is 10. Value will turn out to be 90 joule. Option number A. Clear? So practice more. Okay, and prepare for a maximum number of questions. Okay, be perfect with the concept, and please don't waste your time. Keep studying. Thank you.